Good morning, friends. Today I am going to demonstrate you the segment routing configuration on the Arista boxes. So here I have simulated the VPN VPO scenario. So this is the customer edge side and this is the customer edge 2 side. So I kept the default SRGB values on the EOS, that is 900K, and let's say for the PE1 loopback 1.1.1.1 prefix-sids I kept as 900001, and then for IPv6 it is 902001. So this portion of the network has been already configured with the required protocols. So only today we are going to concentrate on the PE1 side. So let's jump on the configuration part. So this is PE1. So you can see that already we have configured the IP address and we can ping the remote end devices 9.9.13.3. we are able to reach those devices, and if you see the configuration, here it is IP address and IPv6 address enabled for this interface. And for the Arista, because it is switch, so we need to configure no switch to make it the routable port. And if we see here show ISIS neighbor or anything, you will not get any output here because we need to configure the ISIS here now. Before enabling those ISIS under the interface, we need to enable the IP routing for the IPv4 and IP routing for the V6. Then we can configure router ISIS. Let's say core. Network entity title. So I am giving here 49.1111.1111.1111.00, and I am using just the level 2, and then we need to enable the address families for this one, IPv4 unicast, and then for IPv6 unicast. This we are done with the ISIS configuration. Let's configure it under the interface. Ethernet 1, ISIS enable core, and then let's configure it as a point to point. Interface Ethernet 2, IS enable core, ISIS network point to point, and then for the interface loopback 0, ISIS enable core, and let's configure it as a passive. So once we are done with this configuration, our ISIS agency should be bring up. So we can check the ISIS interface. You can see that ISIS agency is up with the P2 and P3 with these two devices. And we should learn all those route in the routing table 2, 3, 4, 5 and 6. Same for the IPv6. So we are learning all those routes. So let's configure the BGP. So before configuring the BGP, we need to enable the service routing protocol model multi-agent. And once we configured it, after that we need to reboot the box. Service routing protocol model multi-agent. Model multi-agent means by default it will be IPv4 address family, and in case if you are going to configure the VPN IPv4, VPN IPv6 or EVPN address family, it will give you error and it will ask you to configure this command first. So once you configure this command, then you need to save it, and then you need to reload the box before configuring the BGP. So it may take to reload the box. So I'll pause it here. So now router is up. Let's see. ISIS adjacency is up. So before proceeding for segment routing, we need to bring up the BGP between PE1 and PE6. Let's configure the BGP. Router BGP 100. Router ID, let's configure 1.1.1. Let's configure the neighbor, which is RR 100. Update source loopback 0. And we need to send the extended community, otherwise your RT will not be exchanged and you will not be import these routes into the VRF. So we need to send those community. We need to enable that address family, and we need to activate that neighbor under the address family. That's it. If we see the show run section BGP, so this is the complete configuration for the BGP. Let's see the BGP status. Yeah, it is up with the router 5. So in this topology, this is the route reflector, and this is the PE6 where we have P1 and P6 where we have configured the VRF. Let's see what route we have received. So we can see that we have received 22, 22, 22, which is advertised from CE to this route. So PE6 has advertised it to PE5. PE5 is RR, and he has advertised that route to PE1. So now let's configure the VRF. But before configuring the VRF, we need to enable the IP routing for the VRF. IP routing VRF ABC. Okay, we need to configure the VRF first. VRF instance ABC. here, and then configure the value, RD value, then you need to configure the IP routing VRF ABC, then interface which stores the CE1, that is it Ethernet 12, no switch port, VRF ABC, and then IP address it's 192.168.1.2/24. So once we configure this IP address, it should be able to ping, no shutdown. Yeah, we are able to reach the CE1 device. Now we need to configure few parameters under the router BGP. So RD, as we got error here, so yes, we need to configure it under BGP as well. VRF ABC, RD is RD is 100:65001. Then we need to define the route target, import VPN IP4 100:65001, and then route target export VPN IP4 100:65001. So this neighbor has been already configured on CE1 side, that's the reason it is sending some BGP packets here. So let's configure that neighbor here on this side, 192.168.1.1, remote air 65001, and under the address family IP4 we need to activate it. So we are done with the VRF configuration, where we have configured the VRF instance, then we have configured it under the interface, then we need to enable the IP routing for VRF, and then the VRF configuration under the BGP. So let's check the routing table, show BGP VPN v4. So we are learning the two routes from the remote PE. So let's see what exactly they say. It's saying that not based, unusable, and invalid. Because to reach that particular next hops, we need the MPLS enable. We need the MPLS to be unable to reach those next hops. That's the reason it is showing that unusable. And if we see the show IP route VRF ABC, we see only the route learned from the CE1. So let's configure the segment routing and see how the routing table changes for the VRF. So first we need to configure the MPLS IP. Then under the interface loopback, let's configure the prefix-sid. So this is PE1, so we will configure the index value 1, and for IPv6 it is 2001, index 2001, and let's enable the segment routing under the ISIS. segment routing MPLS, no shutdown. So that's it. So this is the configuration for the segment routing. So if we verify the VPN VPO entries, detail, so we could see that now it's become valid, and we should see that entry in the VRF routing table. Yes, it has been learned into the VRF. So we should be able to ping now. Yeah, we are able to ping. If we check the show ISS database, let's check the entry for PE1 detail. We could say that adjacency-sid for the neighborship with PE3 for the interface 9.9.13.3, that is neighbor IP address, and we could see that adjacency-sid has been allocated for that one. So this is the for local, because this is the local, adjacency-sid is always local. V is for value, because generally in case of the prefix-sid we advertise the index, but in case of the adjacency-sid we advertise as the value. That's the reason value flag has been set. And EF is for the family. For IPv6 it will set, for IPv4 it will be unset. So this one is for the IPv6 and this one is for the IPv4. So same is the case for the neighborship with PE2. If we see here the prefix-sid for the 1.1.1.1, router PE1 is advertising the prefix-sid n with the flag n, that is node seed, has been set, and same is for the IPv6 prefix where we are advertising 2001. This is the SRLB, that is segment routing local block. In case if you want to configure the manual adjacency-sid, and this is the segment routing global block, that is by default is 900K and range is 65536. So let's see segment routing, show ISIS segment routing global blocks. So we can see that global block is same on all the interface, all the routers, we didn't change it. If we check the segment routing prefix-sid for the all the nodes, so for PE1 index value is 1, for PE2 it is 2, and 3 it is 3, for P4 it is 4, P5 it is 5, and P6 it is 6, and same as for the IPv6. Show ISIS segment routing adjacency segment. So this is the adjacency segment. For the node connected to P2 and P3. So this is the IPv6 where family flag has been set. B flag is for backup, that will be used in the case of TILFA. V for the value, absolute value, L for the local, and S for the set in the case of adjacency set. Show MPLS segment routing binding for IPv4. So you can see the MPLS table has been populated with the entry. For P1 it is 9000001, for PE2 because it's directly connected, so implicit null, and 9000002. Same way it has been populated for IPv6 as well. So if you see the show MPLS signal routing binding for the, let's check for the remote PE, that is PE6. So if we send the traffic from CE1, the label 9000006 will be pushed on the packet and it will forward it towards the next hop. So if you see the show MPLS route, so we can see here the entry for the MPLS routes, the label, incoming label with the outgoing label and its action. And if you check the ping for the segment routing, let's check for the destination. Source is 1. Yeah, we are able to ping. So router is pushing the 9000006 level on top of that. So let's check this trace route. Trace route MPLS segment routing IP 6666 source. So we could see that, as we discussed earlier, that prefix-sid is ECMP aware. So this first portion is going via the top portion is going via the this way, and then second portion is going via this way. So we can see that PE1 will push 9006 level, it will come to PE2, PE2 will just swap it, and then it will come to PE4, because PE4 is directly connected to PE6, so he will do the PHP implicit null, and then finally it will reach to the PE6, and same is for the upper path. So we can see that our control plane is working fine. So let's check the end-to-end ping from the CE. Repeat, let's say 1000, and if we see the wireshark output, let's capture the packet. So this is the ICMP, source is 11 11 11, destination is 22 22 22 22, and this is the 9006, that is the top level push for the PE6, and this is the VPN label push for the 22 prefixes. So let's verify the data plane. So if we check the show IP route VRF ABC 22 prefix, let's check the detail. So we can see that this prefix 116384 we have learned from the PE6, and once we get the packet from C1, we will push this bottom level, and top level will be the 900006, and then packet will push to the next hop. So let's check the entry on the P3 device, and let's verify the operation for the 900006 label under the label forwarding information base. Show MPLS LP route type MPLS 6 detail. So packet is hitting with the 900006, and the P3 is doing the swap operation. So these are two ECMP path we have available towards the destination from the P3 as well. In the both path, it will do the swap operation for the same label. Let's go to P4 and verify the operation. Show MPLS LFIB, route type MPLS 900006 detail. So here we can see that 900006 is incoming label and outgoing label is pop penultimate hop popping, and it is forwarding to on the interface 3 towards the destination, that is PE6. So let's verify the entry on the PE6. Show BGP VPN v4 22.22.22.22/32. So we can see that router will hit this label with this 116384, and then it will remove that label and it will forward over the interface towards the CE2.